Alright, here is the last part for Notes 1.2, picking up with symmetry about the x-axis, y-axis, and the origin. So the first thing I'm going to do here is get this equation to look a little bit nicer. So this is, I'm going to subtract over the x squared, so this is negative y equals negative x squared. Divide both sides by negative 1. We have an equation that looks like y equals x squared, so not too bad. First thing is about the x-axis. X-axis again is you are going to plug in a negative y and a positive x, see what happens. And so plug in our negative y, we get negative y equals x squared. That divided over, you get y equals negative x squared. That is not the same as the original equation, and so that is no to x-axis symmetry. Y-axis symmetry is just the opposite. We're going to plug in negative x, and so this is y equals negative x, but that's squared. And so what we do then, negative x being squared actually gives you x squared. So that one is the same as the original, so that's a yes to the y-axis symmetry. And then finally, origin symmetry, if you have a negative y and negative x squared, you get negative y equals x squared. Dividing it over, that's y equals negative x squared, which is not the same, so no to origin symmetry. So that one had y-axis, and that's it. And it is a parabola with that x squared. That is a parabola, so it makes sense that we have that symmetry, because if we go back up, it's kind of like what we had right here. Okay, moving on, we have circles. So we have the standard form of a circle, which is x minus h squared plus y minus k squared equals your radius squared. My center is at 0, 0, so my h is 0 and my k is 0 because h and k control your center. Then the equation that we have is x squared plus y squared equals r squared, which should remind you of the Pythagorean Theorem or the distance formula. Very interesting. Okay, we're going to use that now. So we want to write an equation that has a center at 2, 3 and a radius of 7. And so if we do that, we have x minus 2 squared plus y minus a negative 3 squared equals 7 squared. And so this is then x minus 2 squared plus y plus 3, two negatives make a positive, squared equals 49. And that would be my equation for a circle that has radius 7, that has its center at positive 2, negative 3. It looks kind of funny because negative 2, and then this says plus 3, but remember, if the original equation has these negatives, that's a positive 2, and then the two negatives making that a positive there. Okay, last one, it's just a point that lies on the circle. So you know a point and you know the center, so you know this is your x and y, this is going to be your h and k, and so we can plug things in. You end up getting 3 minus a negative 1 squared plus 4 minus 2 squared equals r squared. This is going to be 3 minus a negative 1 is 3 plus 1, so that is 4 squared plus 2 squared equals r squared. This is then 16 plus 4 equals r squared. And then you get 20 equals r squared, which square rooting both sides to get rid of that, you end up square root of 20 equals r. And then now we have a radius and we have a center, so we can write our equation. And so we have x minus a negative 1 squared plus y minus 2 squared equals your radius squared, so the square root of 20 squared. And what we'll get then is x plus 1 squared y minus 2 squared equals 20. And that would be my equation for that circle that goes through that specific point. All right, that's it for our notes. Again, remember, ask me individual questions. I can make videos on individual questions. I'm especially happy to talk more about symmetry and do more symmetry problems. So please just let me know, or join our Google meeting tomorrow, Wednesday, from 10:30 to 11:30. And before I go, here is the homework. You can pause, take it down. It looks like a lot, but the beginning ones are pretty easy. And then I try to just cut out as many graphing ones as I could, with still needing to sketch some things. So here's what we have, and make sure you try to get this done before Friday when I see you in class.